Hello everyone, welcome to the second of three probability videos. Today we're talking about experimental probability. Last time we were looking at theoretical probability, and today we're going to get experimenting. So experimental probability means you actually are going to run some trials, some tests, be it flipping a coin or rolling a dice, and today we're going to be talking first about flipping a coin. So I'm going to draw a little coin here. Give it a little 3D action, and we'll say that our condition is we want to flip heads. So flipping heads, and we're going to flip, I don't know, 10 times. So if we're going to say 10 flips, how many out of those 10 flips do we expect are going to be heads? Well, let's think about that. There's an equal likely chance, a 50-50 chance of getting heads. So the theoretical probability of flipping heads out of 10 coin flips is 1/2, or more specifically for our trials here, 5 out of 10. But experimental probability isn't always going to match that. So experimental probability of flipping heads, let's look at these trials that I just ran. So I got heads, tails, tails, heads, 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 tails, heads, 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 which gives me a total of 7 heads out of 10 trials. And as you can see, the theoretical and the experimental probabilities didn't match up. And this is the nature of probability. Experimental and theoretical probability are not always going to match up. But the more trials that you run, say I flipped coins all day and I got over 1,000,000 flips, I would see that the results are going to start resembling the theoretical probability more closely. A good example of this is the weather. Quite often, the chances of rain are predicted as a percentage, 30% chance of rain, 40% chance of rain. And when the weather does not match up with what we expect it to be, or what the meteorologist just told us it's going to be, it can make us very frustrated or upset. So probability is one of these things. It's based on the random, the unknown, so it's not always going to match up with what we're expecting. So I'm going to return here to my game of Skunk from the other day, and we are going to run some trials using our dice to see how long we can go before rolling doubles. And we're going to record our scores in the boxes as we go, and we'll see what happens. So here's my virtual manipulative screen. I'm going to pull up 2 dice here and place them in the space, and then I can actually roll them using this function over here. And I'm going to do this a couple times just to show you what I mean, and return to our game. So we're going to fill in these boxes with the sum of the 2 dice one by one. Alright, let's get rolling and start these trials. So on the first spin, I'm going to get a 7. So I'm going to go back to my other screen and put 7 in my first box. Let's see how far we can get. Now my students will be trying to decide if they're going to keep that 7 score or add another one. So now there's 11. We're on to our third one now, and there you go. We get our first dose of doubles. So this now is where all my students are whining and complaining about losing, and those that were fortunate enough to sit down after 2 rolls are loudly celebrating. I'm just going to finish our trials here just to be able to compare what we get in our experimental probability against what we had last time in our theoretical. So after 8 rolls, I've got 4 already, and I'm just going to keep rolling to see how many more we can get all the way through until those 20 rolls are up. Doesn't look like I'm going to get another one here, so I'll just see. No, quite a long roll without any doubles now. And yeah, so we'll stop it there. I didn't get a single another one there, but I've got 4 out of 20 rolls. And I'm going to write that down here, just 4 out of 20. And I believe our theoretical probability stated that we would get 3, just over 3. So actually, our trials weren't that far off what we were expecting. So there you have it. Experimental probability is determined on the basis of the results of an experiment repeated many times. Thanks again for watching this video, and we'll see you next time for our third and final.